So this is a tripod slash bipod instructional station. It enables you to set this up and then kind of organize all of everybody's thoughts about all the oppositional forces, the directionals, and the ways that you're going to manipulate these high directionals as portable anchors to accommodate any type of scenario or circumstance. So the best way to set it up is to set up your tripod or bipod and find two directional anchors that go to the front and the back side of the tripod or bipod. Go ahead and rig in your anchor straps and all your hardware to establish at least the hub points for tension back ties. In this application, what we're looking at is a Paratech bipod. We've taken 610 struts with the bipod base plates, 635 extensions, and the bipod heads. It's important to talk about angles, which we review in our bipod review, which is just to make sure that you're always within 60 degrees to maximize the vertical loading and not overload the lateral loading on the base plates. As soon as you start widening that angle, you start generating more force laterally on the systems directionally than what they're typically designed to do safely and effectively. All right, so when we establish this, we'll build this, we'll lay it down on the deck, and the first thing that you want to create is that tensioning back tie from base plate to base plate. If you're utilizing your tripod, then it's going to be your chain link. You're going to go ahead and get that run through all the base plates and get it set so that as we squat this, the legs aren't going to kick out. It's particularly imperative with the Paratech bipod because this system can extend and walk out much more so than what a capturing head on a tripod can. So here's our tension back tie on the base plate. We've attached our 1/2-inch rope. We've ensured that our base plates have the silver rig ring on the Paratech base plates oriented towards one another. We've put in G-rated carabiners. We've run our 1/2-inch rope through those carabiners. We're pulling back in a 2-to-1 type of mechanical advantage and then setting our prusiks. We're going to pull tension on these until the base plates start to move inward. Once they start to move inward, we know that we're set, provided that at the head of our bipod, we have not exceeded the 60-degree line markings, or on our tripod that we've maintained the right height and the right extension level on our bipod or tripod legs. Same application applies with the chain, we're just not tensioning it. Once we have the tension back tie established on the base plates, then we're going to attach tension back ties to the back side of the rig and the front side of the rig going in opposite directions. It's important to denote the footprint that the head leaves. So wherever the head is, directly vertically in line underneath that head, that's going to be our location point for our entry. Once you have it as tense as you can get it without overloading these back ties, then you've got a nice tight bipod. It's nice and vertical and in line. We've got our back tie in place. Then we can go ahead and do some basic just lower haul up downs underneath the bipod. In this application, we're using a CMC CSR. Whatever you utilize for this up down or this lower haul, ensure that it's a system that's got an integrated progress capture with a long control point so that you can effectively operate this from the ground level. Utilizing traditional systems in this application, whether they're complex or compound, are going to typically require you to redirect the line through the high directional down to a low directional on one of the base plate legs and then to a primary anchor hub where you're operating this system. So these are a lot more versatile and a lot safer as far as capturing the progress and being able to manipulate the load very quickly. Once you've done it in that straight up and down application, then you can start articulating the bipod. So to articulate this bipod in this direction, or if it were a tripod, we're basically reducing or eliminating the tension back tie that's back here. This tension back tie right here is going to extend out until we get the bipod in the position with the correct footprint that we're looking for. And then we have to create oppositional back ties to the base plates so that they don't kick back in the opposite direction of the load. So in this application, we're running 2 ropes, tension back ties, right at that same primary hub. As soon as you get above or beyond a 60-degree deflection in this, you're really applying, again, tremendous lateral forces this way to those base plates. Since you've articulated, it's imperative that you pin the base plates when you start getting into those really significant angles, even if you are utilizing tension back ties. Anything beyond 60 degrees from an engineering perspective, I would want to pin as well as back tie to ensure that those base plates weren't going to walk back. So here's our tension back tie coming out of the front side of the back of the bipod. Same organization that we put on the base plates. Once we've got it set, we're going to pull tension on this until that bipod, based on someone's perspective laterally, is relatively straight up and down. As soon as it's straight up and down, we'll set our prusik, and then we'll go work on the other side. So now we're on the back side of the tripod. We're going to apply the exact same application. Once we do our initial tensionings on these, this is when we're going to check those legs for stability and start applying more and more tension to each of these back ties, ensuring that you maintain the right footprint on your tripod or bipod, and that you just continue to progress these until you've reduced the majority of the play out of the portable anchor. So here's our first stability check. We give this a little bit of play. We see we got a little bit of wiggle and a little bit of slack in our back ties. So we're going to go ahead and start systematically applying more and more tension to each back tie until we have very, very little play in our portable anchor system. Go ahead and tension on that, Fred. I'll go back and tension this one. You see that those two adjustments took the majority of our lateral play out of the portable anchor system. We've got our CSR all rigged in, and we're ready to do those first segments of vertical up downs now from this application. Fred, go ahead and come on up. When operating these CSRs, it's a good practice to take your control lines, put a quick hitch around the leg of the strut. That keeps the control line out of the way, so it doesn't get entangled, and so that it doesn't get wrapped around your rope systems. It also prevents anybody from pulling on this when you're in a hauling application. When we're hauling the load up, we want to ensure that the system we're utilizing is always going to function in the safest possible application and capture the progress. So from the learning perspective, you can simply haul your loads up, and we can see, as we look at, even though this is a bipod with nothing but back ties, you can see how much stability there is in the system. Even with that load laterally moving a little bit, you have no play and no swing. So we've done a very effective job securing both our base plates as well as the head of this system. Once you're ready to come back down, it's a good practice to utilize the strut as a control point for an arm, so that you're not jerking on any of the systems. If you do them freestanding like this and just try to pull down on the toggle, there's usually a sudden reaction or a quick drop. Also ensure that you keep the rope in your hand as the control man when operating the toggle. And when I initially engage this for the first down point, I have a death grip on this rope to ensure that the rescuer is not going to take a sudden drop. I ease into articulating the cam, and I gradually let that rescuer start coming down to ground. I can change the friction or the speed of his movement by easing my hand up or bringing my hand down harder. That's your first applications for your tension back ties and a basic true vertical organization of your tripod or bipod. Once you want to convert to articulations, we're going to work on those tension back ties to the base plates, not from base plate to base plate, but in the opposite direction, or I should say the same direction as the articulation, opposing what the bipods are going to want to do from the forces applied to them, and we're going to get those rigged in. So here's our tension back ties to resist the forces that are going to be applied to the base plates. We've taken a single rope, we've put a knot on the end, run it through our carabiner, progress capture device or prusik on right here, and tensioned it. We've then taken that slack, redirected it through another carabiner, and run it to the other base plate. Prusik or progress capture device, pull tension on it, and set it. You're applying tension to both those base plates until they start to shift towards the anchor. As soon as they start to move, stop applying tension. Once you're in that position, you're ready to basically take this tension back tie out of the equation. It's not going to serve any more purpose because we're going to articulate the bipod or tripod this way. So the only tension back tie that's going to get loaded is the opposing one, and we're going to extend that one out and walk the bipod or tripod down to the desired angle. Remember, we want to try not to articulate more than 60 degrees. You start articulating more than 60 degrees with these standard tripod bipod applications, and you start to get into some more specialized engineering requirements. So we're ready to articulate now. We're going to pull tension. We're going to release our progress capture device, or our ProSic. And we're going to start easing our bipod out to right about that 60-degree mark. Once we're in the ballpark of that articulation, we set our ProSic, and then we're ready to do those same lifting applications. And you see that we now have an entirely new footprint. Everything's going to be a vertical load. That footprint is now forward of the two base plates. But as we apply load and force in this direction, the base plates, as they want to kick back that way, that force is going to be resisted by the tension back ties going in the direction of articulation. So it's just a great learning lab to set up, to work through all the engineering processes and theories, as well as all the manipulations of bipods or tripods.